Hey, good morning, everybody. Here we are for chapter 13, section 5, and we're going to talk about using our fresh water more sustainably. Now, how do we go about doing that? Well, there actually are a lot of ways. Just cutting out water waste is a big one. We don't want to waste it. Raising the water prices actually help. When something is incredibly cheap, there's no financial incentive to look out for it or care for it. So raising water prices is something that'll actually help. Slowing population growth. This is just an answer for a lot of things. We've got to get that J curve moving more into the S curve. And we need to protect our aquifers, forest, and any other ecosystems that actually store and then therefore release fresh water. We're going to make sure that these are all in good shape, that there are protection laws around them so that we ensure our fresh water supply continues. Now let's talk about cutting water waste. When experts have looked at this, they have evaluated that anywhere from half to 2/3 of the water that we're using is actually wasted in some shape, form, or fashion. Evaporation and leaks are a big part of it. Because if we're diverting it using an aqueduct and the water's just out, well, the water cycle's it's doing its thing. We create our big dams and store it. There's more evaporation going on. So some of that's very expensive to try and fix if we were going to cover everything. But anyway, evaporation is a big part of it. Leaks. A leak in your pipe at home, 1 drip a second, actually is a shocking amount of water over a year. And we're talking about multiple homes all over the place, businesses, you name it. And sometimes we have leaks down at the joints and pipes that we're not even seeing up on the surface. Leaks make up a big part if our pipes haven't been updated recently. And then just plain old inefficient use, not using the water efficiently. It's cheap, therefore we don't think about it, and we just use it and use a lot more of it than we would need to for some of the same practices. And we'll look at some of these ways to be more efficient as we move along. The cost of water to most people is incredibly low, and there's actually a lot of government subsidies out there that mask the true cost of the water. In other words, taxpayers paid to get the dam built, and now the water stored behind it gets diverted off, and we're not really paying for this water because the tax money went into that. This is a way of subsidy. It's not always that somebody's paying for it, but it was subsidized some other way. So this particular person using it isn't paying for it. They're just resting on the backs of all the taxpayers' dollars. Instead, people using the water should have to pay a fair price for the water, and they're going to be much more careful about how much they're using. They're not going to waste it if it's costing money. Also, we don't currently have any subsidies out there really for improved efficiency. We do have some measures where the more water you use, you start paying more money, but there's nothing really completely the other way around, a true incentive. And this is something that we need to look at and address. Now, obviously, if we raise the water prices, this can really hurt some lower income farmers and also people living in cities. If everybody's paying and the price of water goes up, it can be difficult. However, there's a fairly easy solution for it. You just establish a lifeline rate. You provide a certain amount of water, it's still at a very low cost. And this would be enough water for doing your daily living, what you need for showering, for cooking, for cleaning, etc. But if you use more than that amount of water, then you could have some pretty steep price hikes. Here in Gainesville, we have that. We have a tier 1, 2, and 3. If you use water in tier 1, it's much lower. You go to tier 2, it gets more expensive, and tier 3 is even more expensive. So we do encourage people to use less. It's just the tier 2 and tier 3 could be upped much more. But it's this idea of a lifeline. You realize if I only use so much, it's still very cheap. But if I use more than that, the price starts to get really high. And this is something that we can do in cities to help mitigate hurting somebody who's not making as much money. Now, when we talk about waste and water and using it more sustainably, we have got to address agriculture, because that is like 70% of the fresh water is used to raise food, crops, beef, animals, etc. About 70% there, another 20% for industry, manufacturing, and about 10% comes down to kind of you and me, washing our clothes, taking a bath, all this stuff. So let's talk about efficiency in agriculture. Well, flood irrigation. So we're at agriculture, right? We're talking about irrigating the fields, getting water to the corn, getting water to the rice, the alfalfa, whatever it is we're growing. Well, old school, and I'll kind of put the picture up here behind me and we'll talk about them, is flood irrigation. This is just where you put the rows, you put the plants on it, and then we open up the floodgates, something close to the river, and the water flows in and pours into the gaps behind it. So this is a picture kind of on that far left with the water down in the rows. This is flood irrigation. Well, it's only about 60% efficient, if you will. Somewhere between 40 and 45% of the water is lost. It continues to run off, it evaporates out. This big flooding of the field actually winds up wasting a lot of water. It's not getting to the roots where we really need it to be. It's seeping on down through it, evaporating, or running all the way off into the next field or area. So more efficient techniques. What we look at, we have the center pivot. Now that's going to be on the far left one, and this is where you'll see like a crop field with circles. Well, the center pivot, so we've got this big irrigation system and it's moving around the field. Well, the low pressure sprinklers are about 80% effective. So this is where we're putting it, and low pressure, it's just kind of putting a little bit of the water down fairly close to the plant. So it's hovering over the plants and it's putting the water out. I'm not talking about ones that have a big sprinkler showing water out, but these are pointing and spraying the water directly down on the crops. They're about 80% efficient, much better at it. Now, some of them are also fitted with low energy precision application sprinklers. These are getting upwards to 90% in their efficiency. Much better use of our water. The best out there is in the center, and this is drip or trickle irrigation, or sometimes known as micro irrigation. When we're talking about cost of food per drop of water, this is the best out there, somewhere between 90 and 95% efficient. What we do with the drip is you put a hose under the ground near where the root system is, at least on the ground. The best ones go actually under the ground. And then water just drips or seeps out of the tube directly where the roots are. And it's already underground, so we're not getting hardly any evaporation. It's just going into the soil right around the plant, and it's about 95% effective. Why don't we use these highly effective means everywhere? They're costly, they're expensive. Also, the drip irrigation tends to be crop specific. So if I have an orchard and I'm growing my orange trees or apple trees or cherry trees, well, it's very effective because those trees are going to be there for a long time. So we can put this drip system in and we're confident it's going to be there a long time. But if I'm planting some other crops, corn, and then I might rotate the crops, well, the roots are at different depths and temperatures, and it's difficult to do. So they're the best, but only some crops can deal with them, but they're much better in the waterways. And even with the sprinkler system, these rotating sprinkler heads, once again, they're pretty big, so it's a cost up front. And if you're talking about a farmer in a subsistence level economy, they can't afford those. So we'll look at some other options that are available to them as we move along. Well, when we're talking about improving this efficiency, a lot of it really comes down to reducing our irrigation water losses. We've got to cut down on the loss. How do we do that? Well, one of the things is avoid growing thirsty crops in dry areas. We talked about in California, area that's typically very dry, but we're growing corn, alfalfa, and almonds, which are incredibly thirsty crops. Those should actually be grown somewhere where there's more water naturally or already, instead of a dry area where all the water has to be pumped in. We would like to encourage organic farming and polyculture. Polyculture, when we have multiple crops or we have trees over some of the crops, this tends to trap more moisture in again. As long as we have some sort of vegetation on the ground at all times, tends to keep moisture in the ground, better use, more efficient use of our water. Monitoring the soil moisture. How much do we need to water? If we have some sort of monitor so we know when it needs water and how much, once again, we're more efficient with it. These systems are expensive, so if it's super cheap to just water and I don't have to do it, that's what we tend to do. But we've got to turn a page and be more efficient, be more zealous with our use of water, protecting the resource. We want to just expand these more efficient means of irrigation as much as possible. That's where some subsidies need to go, to helping provide for the better irrigation systems that are more efficient, so we're not going to lose as much water. Something as simple as irrigating at night. That way the sun isn't out to evaporate most of the water. Timing it can be at night, but doing the irrigation at night, more of the water seeps in, less of it evaporates out. Some common sense practices, if you will, but they're not, as my dad would say, common sense ain't so common anymore. Sometimes you have that. Some of the canals that we're bringing water in with, if we line them, because some of that water is getting wasted, going down into the ground, not getting it to the crops. Lining them so water doesn't seep down below it. Once again, this is kind of that leakage we talked about. And also we can irrigate with treated wastewater. We'll talk about this idea of gray water coming up. Water that's used for one purpose can still be good for another. Instead of it just being dumped, we need to reuse, recycle some of this wastewater so that it can go out and be used, especially on irrigation things. Now, in the low-tech methods, once again, a lot of these things are great in a developed country such as the United States, Canada, most of Europe, Japan, etc. But a lot of the places in, let's say, Africa, and especially Asia, some countries in South America, it all depends. They're doing some subsistence farming. They don't have the financial outlay for these really expensive systems. Well, one of the things that we've done is getting what we call these human power treadle pumps. So you see the girl up here, it's like riding her bicycle, but this treadle pump, you pump it up and down, especially in areas where the water table is quite high. So instead of doing the flood irrigation, they can do the treadle pump, still using some gravity feed, getting the water to the plants, but it is much more efficient, and it is made with very simple products you can find anywhere. Just this pedal pump, once again, old technology, but it can be done very cheaply, actually quite effectively. Harvesting and storing rainwater, especially in cities where it comes into the gutter and runs off, we need to have things where we can capture and keep that water. Then we can use that water in times when it's not as rainy. We're not getting as much rain, just capturing and keeping the water that we have instead of it flowing off into the drains and out and gone. Capturing water from fog. Some areas receive fog very often, and they can line the hills with cloth and the fog condenses, and catching it again. Once again, using polyculture. Instead of monocropping all this one thing and exposing the soil, polyculture, create canopy vegetation. Once again, all of these things help to reduce evaporation, which and a lot of times is the name of the game, especially when we're irrigating. Most of this water loss is just due to evaporation, and then leakage is the second, and then sort of it's running off. It's not going where we really want it to be. Well, that deals primarily with agriculture, which honestly is 70% of our water use. It's a huge bit. But let's talk about in industry and homes, the other 30%. Well, especially in industry, we need to find ways to recycle the water, especially somewhere like a power plant. Power plants, huge use of water because they have to cool the power plants down. So you bring fresh water in, it warms up, and we put it out. Well, can we use this warmed water for some other purpose? A lot of times we can, and even if we have to like wash my jacket, right? We have to clean it, we have to wash it, all that water. Well, this is gray water, which could be used for agriculture or other purposes. You and I at home, and even businesses like the school that we're in, we want to use low flow toilets. Old school, I remember when we got our house, it still had an old toilet. Thing used like 8 gallons a flush. The new modern toilets use like 1.6 gallons a flush. A huge difference, because you think about how many times you flush a toilet a day. It can be a lot, and that's a lot of wasted water if we can get something more efficient. So low flow toilets, low flow shower heads, even front loading washing machines use something like 30% less water than a top load washing machines. Just getting more efficient machines. Fixing leaks in our plumbings. Anytime you have a leak at your house, address it. Fix it right away. It's just money going down the drain, literally. Using gray water. Now, gray water can be runoff of some kind. There are systems that can be put into house, and use the gray water to water your lawn. Use the gray water to wash your car. Things of this nature to help conserve it. In using water meters. There's still something like 1/5 of the area in the United States don't use water meters, so we don't know exactly how much water is being used. If we don't know how much water is being used, we can't track leaks either. Like say, if our water bill spikes, we look at it, oh, what happened? And we're like, oh, okay, that was the day I was watering the lawn and I forgot about it, let it run overnight. Okay, so it makes sense. But if we start getting a spike in a bill and it doesn't make sense, we begin looking and finding out, do we have a leak somewhere? So metering the water just helps us all track down where it's going to be. Take a look at the picture back here, and what about using native plants in your landscaping? Most of America plants grass, even though grass isn't always the native plant to the area where you live. And if you're planting grass and you're having to water to keep your grass, you may want to consider going with more of a natural landscape. Now, this is a picture of somewhere in South California, but boy, this could be true of places right here around in Florida. I remember when we got our house, there was a sprinkler system in the house, and I very promptly shut it off, and I changed how I mow my lawn. I only mow my lawn every other week. I let the grass get a little taller. That encourages the roots to go a little deeper. So here in Florida, we get enough water, I can keep my grass lawn, but I adjusted the length of the grass, how often I cut it, so the roots could go deeper and I didn't have to water. Now, my lawn may not be the greenest in the neighborhood, but it's fine. And sometimes we have to look at these trade-offs for what's the best way to go. Now, solutions. And some of this we're sort of talking there, but as we look at the graphic back behind us, ways to reduce our water loss. Because when it comes to sustainability, a lot of that is just going to come to reduction. How are we more efficient about it? Our manufacturing processes, can they be redesigned, retooled to use a little less water? Recycling the water that we can. Not all of it can be recycled, but a lot of it can be. Make sure our water leaks are fixed. Landscaping the yards like we talked about it, using all these water saving devices, whether it's washing machines, shower heads, etc. Use the gray water and raise the cost of water. Have the lifeline amount. This is plenty of water for a basic use, and keep it really cheap. But beyond that, the prices need to go way up. There's got to be a fine for sort of misusing water, if you will. So water use and waste. This is just what we need to address. If we can get most of those things fixed, it will go a long way to stretching our water supply. Now, a case study. Californians. How have Californians dealt with their water woes? If you look at the picture I've got back here, between 2011, that is the picture on the left, to 2014. That is the picture on the right of Lake Oroville out in California. This is a reservoir system, and you can kind of tell that by the kind of stream going out through it. However, this is mainly because of drought. It's just over a call it a 4-year period of the reservoir going down this much. Satellite data has shown the lower water levels in the river basins and a decreased snowpack, which is where California gets most of its water. The Rockies, the snow melts where they get it from. But satellite data is showing all of these levels are down. Now, agriculture is using almost upwards to 80% of California's water. They grow a lot of fruits and vegetables out there, but it's traditionally dry land, and we're sending the water to it. And there's been a lot of efforts of Californians to reduce their water consumption. Prices have been raised there on water. They've been encouraged to ship to less water-intensive crops. Once again, the lettuce and almonds are two that just really need to be rerouted from Florida to somewhere else. They're using some desalination techniques. One of the largest desalinating plants on the planet is out, I want to say, supplying water for like about 600,000 people, but once again, using some desalination and restoring wastewater to drinking quality. Once again, the water cycle is what does that naturally. We can treat our water that's wastewater from industry, what have you, into completely drinkable water again without dropping it down and having to run through the entire hydrologic cycle. We can just do some of this ourselves, and California is taking advantage of that. Another one of the things we need to look at is the amount of water that we waste to get rid of waste. Say like flushing the toilets, or washing my dishes, or washing my car, or maybe spraying off my sidewalk, what have you. But just large amounts of water are used to flush away waste. Making my jacket again, right? We had to wash this is actually wool, we had to wash the wool, then you dye it, and you have to rinse that out, and then you get the idea. It keeps getting washed over and over. But this is what I mean by flushing away waste, whether it's washing machines, dishes, what have you. Reusing the wastewater. Currently less than 10% of wastewater is actually recycled. Another thing we talked about low flow toilets, even using waterless composting. There's a lot of ways that we can do things to cut down on this water waste, and we're going to have to in the years to come as our water resources get less and less. Something we have to deal with. Take care. We will see you next time when we talk about flooding. What do we do when we get too much water?